Everyone, Jennifer here, back with another discussion. Today I'll be talking about the respiratory system. The respiratory system is an essential lifeline for survival and is essential to maintain homeostasis. As you can see here from this model, the straw represents the trachea and the balloons are representing the lungs, and the V here, or upside down V, is that is going into the lungs, is representing the left and the right bronchi, respectively. And the balloon at the bottom of the bottle is representing the diaphragm, which is a muscle that contracts and relaxes during inhalation and exhalation. So, going back to the bronchi subdivides into bronchioles. So, think of the bronchi like an upside down tree, as the bronchi are the main branches, while the bronchioles are like the smaller branches off of those main branches. The bronchioles further subdivide into alveolar ducts and alveolar sacs. The alveolar sacs look like a bunch of grapes. And this bunch of grapes, or the alveolar sac, is like the fruit of the bronchi tree. If you think about it like a tree or an upside down tree, because how it subdivides is there's the bronchi, there's the bronchiole, and the alveolar ducts, which would be like kind of like the stem of like a grape that would like go down into the grape, and the alveoli would be like the individual grapes on the bunch of grapes that are hanging from I suppose grapes hang from a vine, but let's imagine they hang from a tree for this scenario. So surrounding the alveolar sacs are a webbing of capillaries. These alveolar sacs are very important for gas exchange, as during inhalation, so you can see the lungs fill up with air, and as you can see here, the diaphragm contracts. The diaphragm contracts to increase the thoracic cavity, the volume of the thoracic cavity, to propel air into the lungs more quickly. So back to the alveolar sacs. How does this process of inhalation, where the air fills up the lungs, the diaphragm contracts, and the thoracic cavity it increases in volume. So how does that affect the alveolar sacs? Well, I found this to be a fascinating process. Is air that is already filtered from the the lungs, right? And also from the sciences have a special mucosa, like respiratory mucosa, that they trap foreign particles and irritants, and the alveoli are not. So the alveoli are not affected by these irritants or foreign particles. As little as possible. A smoker may have, will have a different situation, but I'm talking about the healthy individual that does not smoke. So filtered and humidified air that is clean and free of foreign particles, and also free of irritants. And we'll go back to the special mucosa, the respiratory mucosa, in just a moment. But anyway, the filtered and humidified air flows through the alveolar ducts and through the alveolar sac, and something really special happens where when they go through the alveoli, there's a gas exchange that's happening from carbon monoxide and oxygen. I'm trying to simulate capillaries here. So oxygen is extracted, and carbon monoxide, which is a waste product, is pushed to be expelled out of the lungs and out of the body. And this removal of carbon monoxide happens during exhalation. Oh, this is exhalation. So, just so I didn't confuse you with absentmindedly playing with this bottle, exhalation is the diaphragm contracting. So the thoracic cavity, it reduces in volume. So in the lungs shrink because they're not so full of air anymore. So carbon monoxide is when exhalation happens, it is removed out of the lungs and out of the body through the nasal cavities and through the nose itself. So once again, from this model, inhalation, right? The lungs fill up with humidified and filtered air, and the diaphragm contracts. The thoracic cavity increases in volume. That propels the air to quickly fill up the lungs. So exhalation, the lungs shrink, and the diaphragm relaxes, and the thoracic cavity volume is reduced. So the secondary organs of the respiratory system are the vocal cords, which aid in speech production. So without my vocal cords, I would not be able to talk to you with this discussion right now. So thanks, vocal cords. And also the sinuses are part of the respiratory system. And without them, olfaction, or our sense of smell, would not be possible. So I would not be able to smell freshly cut flowers or freshly baked bread, which would be sad. The respiratory system itself is split up into two tracts. So there's the upper respiratory tract, which consists of the sinuses and like the nasal cavity itself, the pharynx, and the pharynx is subdivided into 3 sections. So, and these would be the sinuses that I was just talking about. The nasal pharynx, the osteopharynx, and the laryngopharynx. The lower respiratory tract consists of the larynx, which is above the trachea, and then the trachea, and the lungs. The structures of the lungs, like I had talked about before, where that is best to remember it like the upside down tree, as it consists of the left and right bronchi, and the bronchioles are like the branches that subdivide from the bronchi, and then there is the alveolar ducts and the alveolar sac, and the individual alveoli. And the alveolar sac itself, remember, like I said before, it looks like a bunch of grapes, and the alveoli look like individual grapes. So, and the alveolar sac itself has a webbing of capillaries around them.